Hey guys, I'm gonna go over the first part of the whoops, that's not the part. Over the homework. So that's gonna be this one right here. Okay. So just so you guys know that the first page that we have here with these two sets of problems. So we have this first set here. We have a second set here. This page is it's a calculator required. These questions require calculator. The next page, this set of problems are no calculator. So, Stephen swims back and forth along a straight path in a 50-meter long pool for 90 seconds. Stephen's velocity is modeled by the given velocity function where t is measured in seconds and v of t is measured in meters per second. Find all the times in the interval from 0 to 90 at which Stephen changes directions. Give a reason for your answer. So, we're going to use Desmos, and I'm going to plot that function that we have here. So 2.38. So 2.38 e raised to the negative 0.02 x, and then sine of, we've got sine of pi divided by 56x. Okay, and this is our function. Okay. So it does tell us that the interval is from 0 to 90, so that's the interval I'm looking at right here. And yeah, also it's probably going to be helpful if I give this a title. I think I can title it as v of x. Will it let me do that? Sure. So velocity, we have velocity. Okay. So find all the times in this interval from 0 to 90 for which Stephen changes directions. So on the AP exam, you have to be able to pick out the important phrases. So changes directions. A particle will change direction along a straight path when the velocity is equal to 0. So pick out the phrases and identify what it means. So change directions means that v of t is equal to 0 and v of t changes signs. So it's kind of both. So v of t specifically, though, changes signs. Okay, so looking at this curve right here, we've got the curve. It's a velocity curve. And something else that's important to know. So Stephen moves back and forth. So what is considered back? That would be when v of t is less than 0. Forth is going to be when v of t is greater than 0. So changes signs or changes directions happens when this changes right here. So looking at this curve right here, above the x-axis would be when the velocity is positive. Below the x-axis would be when velocity is negative. So if I take a look at that point right there where it's equal to 0, that's when it's equal to 56. So v of t is equal to 0 at t equals 56 and changes from positive to negative. That's what we want to identify. And so find all the times in the interval at t equals 56. And what's the reason? V of t changes from positive to negative. Okay. For the second part, find Stephen's acceleration. So that's going to be a of t. Find Stephen's acceleration at 60. So we want a of 60. A of 60 since we know that acceleration is the derivative of velocity, that's going to be the same thing as v prime of 60. So I can easily get that here by doing v prime of 60, and we get negative 0.036. So negative 0.036. Show the setup for your calculations, I just did right there, and indicate the units of measure. So the units of measure are going to be, well, velocity is measured in meters per second. So when I take the derivative, that's going to be in meters per second, or you can say meters per second squared. Okay, and then we're going to ask, it's asking us if is Steven speeding up or slowing down? So speeding up means acceleration and velocity have the same sign. Slowing down means acceleration and velocity have different signs. So we know that the acceleration at 60 is negative, but what about the velocity at 60? So velocity at 60, so we can go back into Desmos and we can just do v of 60, and we get negative 0.1595, so I'm going to round that to negative 1.60. Negative 0.160. So both velocity and acceleration are negative. So Steven is speeding up. At t equals 60. Okay. For the next part, a particle moves along the x-axis so that its velocity at time t is greater than 0 is given by this velocity curve. There is one time t equals t sub r in the interval from 0 to 2 when the particle is at rest or not moving. Find that time. So let's go into Desmos, and this is a calculator required. We're going to type in the function. So we've got the natural log of x, was it x squared? X squared minus 4x plus 5. And then we also had minus 0.2x. All right, so here is our function, and we're specifically looking at the interval from 0, in the interval from 0 to 2 when the particle is at rest. So particle is at rest is going to mean when v of t is equal to 0, when the velocity is equal to 0, find that time. So we've got this 0 to 2. This is the velocity curve. I'll label it as such, so I'll call that v of x is equal to, and if I click on the x-axis, I have that 0. So the x-intercept 1.426. So this time t sub r is equal to 1.426. At that time, that's when the particle is at rest, or I guess you could say changing directions technically. But yeah, okay. Is the particle moving to, so on this interval, which would be 0 is less than t is less than 1.426, is the particle moving right or moving left? So moving right would mean that the velocity is positive. Moving left would mean that the velocity is negative. So what is it? So to the left of this 0 right here is the velocity positive or negative. The velocity is positive because this is a velocity curve and it is above the x-axis. Be sure not to look at the slope of this curve. A lot of students will look at the slope of this curve and say that velocity is negative. If this were a position curve, they would be correct. But it's a velocity curve. So if you're looking at the slope of this curve right here, and then saying that it is moving left because the slope is negative, that's incorrect, because the slope of this curve is acceleration, and that if acceleration is negative, that does not mean you're moving left. So this is moving right. So I would say moving right because velocity is positive. On this interval. And for 4, we're going to find the acceleration of the particle at t equals 1.5. So we want a of 1.5. A of 1.5 is going to be v prime of 1.5. So go in here, and now we want the acceleration at 1.5. So I'm going to say v prime of 1.5, and I get that that's equal to -1. Is the speed of the particle increasing or decreasing at that time? So speeding is increasing or decreasing. That's the same thing as speeding up or slowing down. And so we also need to indicate what the velocity is. So velocity of 1.5, if we go back here, we're going to say v of 1.5. And we get -0.077. So both are negative. Both velocity and acceleration are negative. So the particle is speeding up. And there you go. All right, for this next part right here, it's a no calculator, but we're going to be doing pretty much the same stuff. But yeah, definitely going to be more difficult because we don't have that curve, or we don't have the function to kind of see the curve. So you're just going to have to use more algebraic methods. So we have two particles, h and j, and they're moving along a straight line, the x-axis. For 0 to 5, the position of particle h is given at time t is given here. So this is the position function. And the velocity of particle j, velocity, is given here. Find the velocity of particle h. So I would know that the velocity of particle h would be equal to the derivative of the position of h, which would be equal to e to the t squared minus 4t times by 2t minus 4. Show the work that leads to... Okay, so there we go. Okay, so I think that's all we need to do. Oh wait, no, we need to find the velocity of the particle h at time t equals 1. So we need to find vh of 1. That's going to be equal to e to the 1 squared minus 4 times by 2 minus 4. So that's going to be equal to e to the negative 3 times by negative 2. This is a no calculator, so that means that exact answers are acceptable. So you can leave this as negative 2 over e to the third. Okay, during what open intervals of time t from 0 to 5 are particles h and j moving in opposite directions? So this one, we did a one in class where we talked about where particles are moving away or towards each other. This is not the same type of question. This isn't asking if the particles are moving towards or away. It's just asking when they're moving in opposite directions. And so that's not the same. This is actually easier because I don't need the positions of these particles on the line. So, but moving in opposite directions would mean that we would want to know moving left or right. So move left, move right. Where are these particles moving left? Where are these particles moving right? So that would mean moving left would mean that their velocities are negative. Moving right would mean that their velocities are positive. So we want to know all these intervals right here. So let's take a look for h. So we have the velocity of h. We found it here. So we'll take the velocity of h, which is equal to e to the t squared minus 4t times by 2t minus 4. And we're interested in knowing when it's moving left and when it's moving right. The best way to know when it's moving left and moving right would actually be to first find when it's equal to 0. If I find when it's equal to 0, then I can it just becomes a lot easier to tell. So I'm just going to set this equal to 0. One thing to note is that this part right here, we have a product. So whenever we have a product and it's equal to 0, one of these parts are going to be equal to 0. But this part right here never equals 0 because it's always positive. It's never equal to 0. It's actually always positive. E to any power is always positive. Doesn't matter if this is a positive or a negative number. And the thing is about this right here. So again, no matter what this comes out to be, if it's positive or negative, e to whatever power is always positive and never 0. So that means that this expression will only equal 0 when this part only equals 0. The AP exam likes to use the zero product property. Algebra does too. The zero product property is it's your best friend, honestly. It's a property that you use all the time. So when will this equal 0? When this equals 0, and that will equal 0 when t is equal to 2. So now that we have an idea of when this will be equal to 0, it helps us kind of break it down. When is it moving left and moving right on this interval? So now we just have to split this interval right here into two parts. From 0 to 2, so what about from 0 to 2, and then from 2 to 5? So this interval right here, I know that it's going to be 0 at t equals 2. That means between 0 and 2, that can help me decide if it's positive or negative, and positive or negative here. So let's think about values that are in between 0 and 2. If I plug in values that are between 0 and 2 into the function, and I don't need to plug it into this part because it's always positive. So if I plug in values between 0 and 2 here, well, take 1 as an example. This becomes 2 minus 4, so this would become 0. So any value between 0 and it becomes negative. Any value between 0 and 2 being plugged in here makes this negative. This is always positive. So any number between 0 and 2 makes the entire expression negative. And then if we think about values between 2 and 5, take 3 or 4 or anything in between them, if that's being plugged in right here, that's going to make this positive, and this is always positive. So our expression here is always positive. So the velocity for h is negative from 0 to 2, positive from 2 to 5. So now we just need to think about the velocity of j. And the velocity of j is given in the problem as 2t t squared minus 1 to the third. And again, we're going to set it equal to 0. That kind of helps us determine where we can split up our interval. Well, this will equal 0 when t equals 0. Not too helpful for us because that's the start of our interval. But it will also equal 0 when t is equal to 1. When t is equal to 1, this is 1 minus 1. So we know where it's being split. So we have from 0 to 1, and we have from 1 to 5. So if we think of numbers that are between 0 and 1, if that's being plugged in right here, that's positive. And then if I plug in values between 0 and 1 here, well, let's think about that. If we have a half, for example, or a fourth, and if we square that, that becomes something that's less than 1. And then a number less than 1 subtract 1 will actually become negative. So negative times a positive is going to be a negative. So I know values between 0 and 1 here are going to be negative. And then if I think about values between 1 and 5, if I plug it in here, it's going to be positive. If I plug it in here, any value between 1 and 5 is actually going to make this positive as well. So this will be positive. Okay, so now let's go back to your question. We've done all the hard work. Now we just got to make our conclusion. When are the particles moving in opposite directions? So from 0 to 2, it's negative. From 0 to 1, it's negative. So I know that between 0 and 1, they're both going to be negative, which means they're moving in the same direction. From 2 to 5, it's positive. From 1 to 5, it's positive. So that means from 2 to 5, they're both positive, which means from 1 to 2, that is where they have different signs, because from 1 to 2, this one is positive, but from 1 to 2, this one's negative. So from 1 to 2, I guess I could say VH and VJ have opposite signs. They have opposite signs and therefore moving in. And so they are moving in opposite directions. And there you go. That will do it for that. For 7, it can be shown that the velocity of J, the derivative of the velocity at 2 is 0. So in other words, the acceleration of J at 2 is positive. Is the speed of the particle J increasing or decreasing, or neither at time t equals 2? So then I also want the velocity of J at 2. So the velocity of J, so here is the velocity of J. Let's plug in 2. So that's going to be equal to 2 times by 2 times by 2 squared minus 1 cubed. So that's going to be equal to 4 times by 3 to the third. That's definitely going to be positive. So I'm just going to say positive. I don't really care what it is. Honestly, you can tell that's going to be positive. And so because the acceleration is positive and the velocity is positive, I guess I should include 2, is positive, and the velocity at 2 is positive. Speed of the particle is increasing, so speed is increasing. Okay, and that should do it for these questions.